In this demo, we will see how to use Simulink to invert the images on a Raspberry Pi board. In simple words, image inversion means that the black portions of the image becomes white and the white becomes black. For this, I have MATLAB, Simulink and Simulink support package for Raspberry Pi installed. If you do not have the support package, you can go to the Add-ons tab and click on Get Hardware Support Packages to follow the process of downloading and installing the desired support package. I have a Pi 2, camera board, Ethernet cable, and an USB micro B cable for this demo. To get the connections right, plug in the camera board to the CSI connector port on the Pi 2. Also connect the Ethernet and USB cables to both the Raspberry Pi board and your computer. To get started with Simulink and its support package for Raspberry Pi, I have this example which will blink the Raspberry Pi onboard LED. Here, the pulse generator block will produce a pulse that goes between 0 and 1 once in every second. To feed the LED block an on or off type of signal, we need to convert to a Boolean value. All the blocks in this model have come from the Simulink library browser. Click on this icon to open the library browser, which has all the blocks from all the toolboxes that I have installed. In the library browser, blocks are grouped into categories so that they're easy to find. Simulink support package for Raspberry Pi tab has all the blocks that are available in this support package. There are blocks that can help us communicate with GPIO pins, interact with the onboard LED, send and receive UDP packets, etc. I have pre-configured this model to generate and download code to Raspberry Pi 2. The mode of simulation for this model is normal, and the other one, which is of relevance to the Pi users, is external. External mode provides you with capabilities to modify parameters while the code is running on the hardware and also to monitor signals inside Simulink. When a model is in normal mode, you can download the code to your Raspberry Pi hardware by clicking on the Deploy to Hardware button. Simulink starts preparing the model for code generation and then generates code and downloads it to the Raspberry Pi hardware. Now that we have seen how to use Simulink to generate code for your algorithms and deploy it to hardware, let us see how to perform image inversion. Click on the Search Documentation tab in the top right corner. This is one of the many ways to get to the documentation's homepage. The tabs Functions and Blocks will be of help while using the support package. Documentation pages about blocks will give you the name of the block and a simple description for the block itself. To understand how to invert images on Pi 2 using Simulink, we are going to use the video capture block. This block is set to be used with USB camera, and since we are going to use it with the camera board, we need to search Add Support for Raspberry Pi camera board. I'm following instructions from this page and evaluating this section of code. The output looks similar with what is provided in the documentation, which means that the camera board is now ready to be used with the video capture block. We have an example that is shipped with the support package to invert images. In most of the documentation pages that describe a shipped example model, there will be a hyperlink provided to open the example. This model is also pre-configured to be used with a Raspberry Pi board, like the blinking LED example that I had created. To show how to configure your own Simulink model, I'm going to create a new model. To match it with the example model, I'm going to drag a video display block and video capture block from the Simulink support package for Raspberry Pi. We need sum and constant block, which we can find in the commonly used tab inside Simulink. In this image inversion model, I am going to manipulate only the red component of images and not the green and blue. I'm trying to change all the parameters in the model to make it look similar to the shipped example. To connect the blocks, when we see a plus sign on top of the arrow pointer, left click on it and drag the mouse pointer to the arrow on the receiving block. All of this must be done while holding the left click button down. To configure this model for Raspberry Pi, we can go to Tools, Run on Target Hardware, and select Prepare to Run. If a Raspberry Pi board is connected to the computer, then Simulink tries to auto-populate the target hardware information and other useful information. Once you confirm that these are accurate for the current connection, click OK and save your Simulink model. If we click on the Run button, we should see the inverted image of my Pi 2 after Simulink generates and downloads the code. As mentioned earlier, in external mode, we can monitor signals as well as modify parameters while the code is running on target hardware. For this, I'm going to change the value of constant block and see how that impacts my image inversion algorithm. With that, we have seen how to create our own Simulink model that can be sent to Raspberry Pi hardware to perform image inversion using the Simulink support package for Raspberry Pi.